So last time we introduced the multi-part format, and we saw that this is the structure of the requests that we're going to get. And today let's talk about parsing these things. So let's parse all the important information out of requests of this format. And I feel like this has been coming up quite a bit in like office hours and just general. To get test cases for your homework, the intent is like the handout code, the code that you get to start homework 1, it'll get requests and then immediately print out those requests. Actually, I have it open. It'll get the requests, and you all have like this code I put in the homework handout. This will print out whatever is received. So as soon as you get a request, it'll print it to the screen in bytes. So to get your test cases, spin up your server, send it a request, and you have that request printed in bytes. Copy that, paste it into your test cases, and you have a test case in the exact format that you're expecting. Specifically for homework 2, when you're doing the registration and login, the extract credentials, fire up your server, fill out the form, one of those two forms, or both of them, click submit, and then go to your console where you're running your server, and you have an exact, properly formatted test case for your code. You can make sure your code works well on those test cases. And the format's slightly different for login and registration, so create a test case for both of them, and make sure you have exactly the test case you're expecting. The number of times I see, well, it was like 2, but 2 out of like 3. So 66% of you are, that's not how it works, but are using username and password as the names for the inputs instead of username underscore login, username underscore reg for the field names for those things. So you can use your front end to generate your requests, and when we get to multipart, not especially, but also when we get to multipart, get a beautiful test case in exactly this format. Create your multipart form. For your first test case, you can use that profile image. I left that profile image form on the front end. We're not using it this semester, but you can use that to generate your first test case. Would be fine. And create a form with a whole bunch of inputs that's multipart encoded. Submit a submission, use that as a test case. Let your browser generate your test cases for you. Don't try to manually write your test cases. It's fine to manually edit them as long as you're really careful with how you're doing it. But if you're generating your test cases from your browser, using that code that I gave you in the handout, which, I mean, I say the code. All I did was print to the screen. But if you print those to the screen and use browser-generated test cases, you know they're going to be in the exact format that's expected. Okay, so let's pick up how to parse these things. The first thing that we're going to do when parsing multipart is decide if we have a multipart request. We don't want to run our multipart parsing code on a request that's not multipart because we're going to get all kinds of index out of bounds errors and just all kinds of bad stuff going on. So to do that, what you can do, like what the proper thing to do would be to check the content type and check if the MIME type is multipart form data, and then you know you have a multipart request and you can run all your multipart parsing code on that. For our purposes in this class, I'm not going to get mad at you if you make assumptions of the content type based on the request path and method. I get a post request for whatever you chose for your form path. I did /form-path. But whatever you choose for form submissions or multipart form submissions as your path, and your HTML that you write, you're going to write your HTML and put some path for submissions. Whatever you choose there, you get a request at that path, you can assume it's multipart. You can't trust the front end, so maybe somebody changed that to not be multipart. And you know what? They're just breaking the functionality for themselves. I'm not concerned about that. You can just assume that, okay, I got this request. It's going to be multipart. Let me launch my multipart parsing stuff. Out there in the industry, you should probably at least double check the content type, but I'm not sweating it in 312. So we're going to check this, and we're going to say, okay, we got ourselves a multipart request, so let's handle it as a multipart request. We're going to check the content length. This is a bigger conversation I'm going to save for Friday when we talk about buffering, but I just want to foreshadow it right now. We're going to check the content length to see how many bytes we have to read in the body. This will become a lot more important now that we're supporting file uploads. You'll notice you need the content length to be exact. You find this out, well, I guess you only find this out if you made a mistake, which I assume most of you probably did, at least possibly on purpose, if you didn't make one on accident. But messing up your content length on homework 1 or any homework, the browser is going to take you seriously. Whatever the content length you put, the browser will take that as absolute fact. It will take that content length and read exactly that many bytes. And if your content length is larger than the number of bytes you actually send, the browser will sit there and wait and say, well, you told me you were going to send me 9,937 bytes, but you only sent me 9,936. I'm looking at the number, I still got it wrong. 36. And the browser's going to say, I'm going to sit here and wait for that last byte. I'm going to sit here forever, as long as I have to wait for that last byte. Because you told it how many bytes you were going to send. That last byte, from the browser's perspective, is on its way, but it's going to say, well, maybe you had some Wi-Fi issue, or not Wi-Fi, it's a server. But maybe you had some networking issues or something. Maybe something happened where the server's just getting bogged down for a little bit, and it's going to wait for that last byte because you told it that last byte's coming. It's going to sit there and hang. If your content length is less than the amount of content you're sending, the browser's going to read exactly content length number of bytes, and those extra bytes, it's going to leave there and just throw it away. It's never going to read those last bytes and just use the ones, the first content length number of bytes. So content length is very important for some reasons. We are going to talk about them. I don't know how much I want to say today. I'll save a lot of it for Friday. But there's another slide where I'll talk about this a little bit more. So we're going to make sure this content length is right. And when we're on the other side, the foreshadowing part is we have to make sure we read exactly this many bytes, which is going to be larger than 2K for what it's worth. So in your code right now, in the handout code, there's no reason to change this, so you probably all have the same thing right now. You're calling the receive method, which for some reason they delete half the letters. It drives me nuts when programmers do this. Don't delete half the letters of your method. But the recv method that you call, like the first thing your handle method does, is going to call the receive, and that's going to read bytes off of the TCP socket, off of that stream, and it's going to read up to the number of bytes that you give it as an argument, which by default is 2K. If your request is fewer than 2K bytes, that's fine. It's going to read the entire request. But when we have this request that's almost 10K bytes, actually it's going to be over 10K with the headers, then we can't read this just by saying, give me up to 2K bytes. So we're going to have to buffer and read from the TCP socket multiple times to get the entire request to be able to start parsing that. So we have a lot more conversation about content length moving forward. But for right now, just foreshadow that we're going to be on the other side of that. We're going to be doing the same thing the browser's doing, where it's going to hang if that's off by a bit, or not get all the content if it's off by a bit in the other direction. But the browser is going to set the right content length, so we ain't going to have to worry about that part. But we're going to take that content length seriously and read exactly that many bytes. Okay, back to parsing this thing. Once we do have the whole request, we're going to do our buffering that we'll talk about on Friday. Once we have all that and we have the entire request already handled, I will talk about buffering a little bit more on a later slide today, though. Once we have the whole request, the first thing we want to do is extract this boundary. So the way a multi-part request is going to be structured is multiple parts, and those multiple parts are going to be separated by this boundary sequence. There's a lot of little details that we'll talk about when we get to them all. But notice, for starters, this is going to be in the content type header, and this uses the same format we used to specify UTF-8 when we said char set equals UTF-8-8 is the same format. It's the MIME type, semicolon, and then boundary equals, and then the actual value for the boundary after that. So this is going to be where your boundary is going to be specified, and then you use that boundary to separate the parts of the request. This example has two parts, and this is a form. I created a form, which was the one from earlier in these slides. Actually, I didn't show the HTML again in the other lecture. I probably should do that. It's this form right here. I have two inputs, one text input with the name commenter and one file input with the name upload. So I have two parts in my multi-part request, one for each input. And if I had 5 inputs here, I would have 5 parts on my request. And for my testing of LO1 on homework 3, which will be out by tomorrow, I'll get it done by tomorrow. It'll be, what was I saying? I'll test with at least 3 parts. I think I'm going to test with up to 5, just to make sure you're parsing any generic multi-part request. But this is the form that generated the input that we're looking at on our example, our request from our example here. So I have 2 parts, and each part is going to contain the name of the input. Commenter is going to be the name of that input, and then whatever I typed in when I created this example, my name here, and then name upload for the other input, and the actual bytes of that file that's uploaded. We're going to use the boundary to split our content into these parts. So let's talk about how we're going to extract these parts. I know we spoke about it last lecture, but does the router just take over the functionality of handling the response sent back to the user, which we were originally doing in server.py? So the router, when you call handle request, is that what I named that? Route request? Whatever I named it. It takes a request and returns bytes. And the bytes, that's going to be the bytes of the response that you send to the user. So everything in the middle there that your server.py used to do, the router is going to not necessarily do, but it'll call the appropriate function that does the thing, that turns a request into a response. All right, so these boundaries. There's a lot of little nuance with this one, a lot of little things to get to keep in mind when you're parsing these things. And every one of these, I'll give the warning right up front, this has to be byte for byte perfect on these things. We need to extract the exact bytes. I might as well go on this rant right now. I did it in the other lecture. But I used to not have the LO1s auto-graded. And for this objective specifically, I was just like support file uploads, and it was up to everyone to do it however they wanted to do it. And there was a lot of cheese, a lot of really crappy code. Students would do things like look for these blank lines and look for some dashes without actually reading their boundary. A lot of really, really, really bad code. And then they would have some extra bytes in their file. They'd have some extra crap when they finally extract their file. And then their file is corrupted and the images don't show up. And they're like, I don't know why these images didn't show up. So I want to make sure everybody has some solid parsing code where we're paying attention to all these details, or else I'll get, like there's a new line character, there's a /r/n right here that's invisible, there's a couple extra dashes right here, and students would have those 4 extra bytes at the end of the content of their file, which will corrupt, depending on the encoding, depending on the file type, that might completely corrupt the entire file. At worst, it's going to corrupt a little bit of the content of the file, and the image doesn't show up exactly the way it's supposed to. So we want to make sure we're byte for byte perfect on this parsing, so we need to pay attention to all these little details of how to parse these things. Bless you. So the boundary, and this one I don't know exactly why this is part of the protocol, but the boundary is what I have highlighted here. That's probably a little hard to see. But the boundary from the header is going to be part of what separates the content, but it's going to have 2 leading dashes. So we have 2 extra dashes at the beginning of the boundary each time it shows up, and we have to be expecting those dashes and look for those dashes. If you're using a Chromium browser, which is what I use to generate this input, the boundary itself starts with a whole mess of dashes. This one starts with 4 dashes, so it's kind of hard to eyeball those 2 extra dashes sitting there. If you're not aware of what's going on and looking for those things, you might miss that. But we have 2 extra dashes here. When you're testing Firefox, I forget off the top of my head what Firefox uses, but they'll use a different boundary. It's not going to be 4 dashes, WebKit boundary, and then some crap. It's going to be something else for the boundary. So these extra dashes will be here, and every boundary is going to be preceded by a CRLF. So this boundary here and this boundary here are both preceded with dash and a CRLF, because each boundary has to appear at the beginning of a new line. That's a little different for the first one because the first one is already preceded by CRLF, CRLF. So there's not a third CRLF here. So little nuances like that is what I'm talking about. We have to be careful about everything that we're looking for. But in general, we have this boundary that's going to separate the parts of the request. And each boundary is going to be followed by a CRLF as well, at least the two that are highlighted here. CRLF that starts the headers that we'll talk about in a second. The last time that the boundary shows up, it's going to be preceded by the CRLF dash dash, but it's also going to be followed by a dash dash. And there can be content after that last dash dash. So once you see dash dash, boundary dash dash, that's saying this is the last boundary. There will not be anything relevant to the parts of this request after that point, after that last dash dash. But that doesn't mean there's going to be nothing there. There might be nothing there. There might be a new line character there. There could, the protocol, the RFC, does allow for anything to be after this, but we have a way to indicate that this is the end of the parts, but there might be extra stuff after that. I haven't ever seen anything after there, but there could be, according to the protocol, it's allowed that there can be extra stuff after there. So anything after this last boundary needs to be ignored. And then once we do all our boundary stuff with all our dashes and extra new line characters and all that stuff, then we have each part of the request separated, and each part is going to have its own structure, which is very similar to an HTTP request. So if we're lucky, I say lucky, but if you use good practices, you should have in your header class, what am I saying? In your request class, you should have a method or a function that parses your headers and split the task into several subroutines. What a lot of you have done that I've seen, and probably a lot of you in general, is, because left to your own devices, not just students, but developers all over the world will do the simplest thing, is your entire request class, all the logic for that is in the constructor, which is bad, but man, it's just a losing battle. I get sick of recommending better practices. I'm trying to push better practices in 312 this semester, but there's only so much I can force, and anything I don't force won't be done, but by most of you. But hopefully you wrote your code in separate individual methods. I like to have a method that looks for the first /r/n/r/n and separates the headers from the body. Another method or function that's going to go through my headers and parse all those. And then another one for my cookies, to split up my cookies into a dictionary and split all those into separate methods or functions. If you did that, just call those methods or functions. Just call them again for this. You could even create another request object and have that do all the parsing for. Actually, even if you, now that I think about it, even if you did everything in the constructor, create another request object because it's going to follow the same format. There's a few differences. There's not going to be any request line. So there's no line that says method path HTTP version. There's none of that. So hopefully you have your separate functions that you can handle that. Or finding another way around it to be able to reuse all your code in the constructor. It's fine too. Regardless, what I'm saying is you shouldn't have to write new code for this if you have things set up in a well-structured, architected way. You should be able to reuse your code here without cut and pasting, or some of you will just cut and paste, whatever. I'm not going to fight that battle. So the format is any number of headers, a blank line, and then the actual content of this part. And then I consider this CRLF right here to be part of the boundary, so I'm not mentioning that CRLF again. That should already be gone. You should already have that parsed out by the time you get to this point, is what I'm assuming. So hopefully you can reuse your code there. It's intended that this step is pretty easy because you already did it. And once you have this parsed and you're starting to look at the headers, let's look at what information we have here. Content disposition, I went through some of it already. The big piece of information that every content disposition header is going to have is the name of the input from this part. And the content disposition header, it's not strictly required by the RFC, but everything you parse in this course is going to have content disposition on every single part to the point that you can assume that it's going to be there. Write your parser to just assume you will have a header named content disposition in every single part. The content disposition is added by the browser when you submit an HTML form, which is our use case, so it's going to be there for us. The RFC doesn't require it because you can use multipart, form data, the MIME type, without an HTML form, and you might have some different use case where you just do something different. But we're going to have content disposition that says it comes from a form, and here's the name of the input. And for files, it's also going to have the original file name that the user submitted, which is something we're usually not interested in, but it is there if we want it. If you've read through homework 3, if you read through that LO3, you might be interested in the original file name. Not strictly interested in it. You don't have to ever look at the original file name in homework 3 because AO1, I'm going to say this for like the 3 of you who've read all this. Well, maybe more of you have. That's not fair. But AO1 is a superset of LO3 functionality. So you can completely skip LO3 on homework 3 and go right to AO1. If you're planning to do the application objectives anyway, I would skip over LO3 entirely and just go to AO1. AO1 is going to do the same functionality plus more, so it'll imply that you completed the LO3 if you complete AO1. So, but if you're doing LO3 but not AO1, that's the only time you would want to read the file name for the homework. In the real world, you really don't care about this file name. Like, we don't care about it. But for a good user experience, I've been saying UX all semester. I don't know if I defined it yet, but when I say UX, I mean user experience. For a good UX, you might want to store this file name. For a good UX, you might want to store this file name because if a user uploaded a file and you're going to show the user like the files that they've uploaded, you're going to want to use the original file name because that's what the user would expect. That's how they're going to identify the file. When we save this to disk, we'll talk about this on a later slide, but when we save this to disk, we're going to use our own file naming convention, which we should use our own file naming convention. Don't use the user uploaded file name. Quick reason why is what if 2 users upload files with the same name, or the same user uploads a file with the same name 2 separate times? We want to treat that as 2 separate files because they might have different content. They'll just be 2 different versions of the same thing that they're uploading, whatever it is. You want to save both files. If you're using these file names, you're going to have name collisions. So we might want to save that for UX reasons, but we will still save that file using our own file name when we save it to disk. But again, for 312, I don't care if you just throw that file name away, unless you're doing LO3 without AO1. Okay, which some of you will do. I expect that, the AOs, you can tell from homework 2, like the AOs are starting to get tougher. I won't even blame anyone if they do, focus on the LOs only, but so in that case, going on too much of a tangent with it. I'm done talking about the file name. All right, so content type. This is where we're going to start seeing differences. I mean, content disposition doesn't show up in HTTP either, but we're going to see differences from HTTP requests and these parts. We're going to see content type only if the content isn't plain text. So if the content type isn't present, it is optional here. If the content type isn't present, the MIME type is assumed to be text/plain. So in this first request, which was generated by an input of type text, there's no content type. It's just plain text. We don't need a content type for this. The next one, I uploaded an image. So it's going to specify the content type and say this is image/PNG. The user uploaded a PNG image for you. And there's no content length. You'll never see content length. You shouldn't anyway. I don't know why a browser would ever do this, but you won't see content length on these parts. This is completely missing, and this is where I want to talk about buffering just a little bit more. The whole reason of content length, which I don't think I talked about, we'll talk about at length on Friday, but the whole reason for content length is to make sure you've received all of the information and exactly the right amount of it, the right information. So we say content length on the HTTP header to say this is how many bytes you should read after the headers, after this blank line. I'm going to send you this many bytes, so don't process this request until you get this many bytes exactly. So it's going to sit there, it might buffer, it might read from the stream multiple times, it might do whatever it's going to do to make sure that it reads exactly that many bytes before processing this request. So we don't lose any data and we don't read extra data that's not part of this request. And part of this is, like in practice, you reuse the same TCP connection for multiple HTTP requests. That's what that keep alive header is. So you don't want to overshoot. You don't want to just say, hey, read everything I send you, because part of what you send might be a second request on the same TCP connection. So content length also makes sure that they're not overreaching and starting to get into the request line and headers of the next request and add those as the end of the current request. We don't want to do that. So the content length makes sure we get exactly this request and this request only. And if there's another request line headers right here, we don't want to corrupt that next request. So it's really important to get the exact number of bytes for content length. Once we are extracting the parts, once we're parsing the parts, we don't have the same problem. We have the entire request. We absolutely know for sure that this is the data that we're after. So that in this request, we already know that this is the whole part because we did the WebKit boundary stuff and the content length for the HTTP request itself. So we know that we have everything here. We know after this blank line and up until the /r/n -- boundary, we know that everything in between is the content. So we don't need any extra mechanism to tell us how many bytes are there. We're just going to figure it out. Like we have all the information we need to figure it out, so there's no need to have content length on the parts. That's why the question nobody asked, but that's why content length does not show up on the parts. And then finally, we can extract the bytes of the file, but we have an issue here that we haven't talked about yet. We've talked about this throughout the course a lot. But the bytes of this file might be binary. It might not be text information. So when we're parsing multi-part requests, or any request for that matter, up until the point that we can verify it's all text, we cannot convert the request into a string. Because the bytes of this file for our homework 3, it's all multimedia, it's images and videos. This cannot be converted to a string because it doesn't follow any string encoding. So when we're parsing this request, if the first thing you do when you get a request is say .decode, that's going to be wrong for multi-part requests. And I didn't require this on homework 1 just because homework 1 had enough going on in it. But you might have to update your request code when you get to this one, because this is the first time that we're going to have binary, just raw binary bytes that don't encode strings in a request. So if in your request class, the first thing you do is take the constructor parameter, take that variable and say .decode to convert it into a string, and then do string parsing on your request, you'll have to change that to do your parsing in bytes, because the body is going to contain something that's not a string, and you don't want to corrupt the bytes of that binary file. And you may have wondered, why would Jesse do this on the request class? Have the body be bytes? I had that B on the string, so it's a byte string. And if you extract the body in a string, then you have to re-encode it as bytes, or else Autolab's going to complain and you're going to get type errors. The reason for that is exactly this. I didn't mention it when we were on homework 1, but this is the exact reason, is sometimes the body will contain something that's not a string. So when we're parsing that, we have to make sure the body is never converted to a string until we can guarantee that it is going to be a string. Like in this request, we can't ever convert this to a string because it has a file. For homework 1, every request happened to be string. Well, it didn't just happen to be, but homework 1 and homework 2, I made sure every request contains only string data, so we can safely do that, and then I could save the conversation for today. We can start talking about it now for homework 3. But now that we're in homework 3, we can't use our string parsing anymore. What do? We're going to parse in bytes. We're going to transition into everything being bytes. So we can't convert it to a string and use all our string functionality and methods. Byte parsing at this time. So we move from string parsing to byte parsing. Luckily, in Python, this is why I used to recommend Python for the course, and now I just require Python for the course. One of the reasons is byte parsing in Python is basically the same exact thing as string byte parsing in Python. It's got all the same methods. There's a split method. There's a contains method. There's splitting your byte arrays. You can use the array splicing syntax in Python. You have so many tools available to you in Python. In a lot of languages, working with bytes is quite painful. Python makes it pretty much as easy as working with strings. I don't even know, I can't think off the top of my head what methods I'd want that don't exist in bytes that do exist in strings. There's a find method. You can look for a subsequence of bytes and get the exact index of the first occurrence of that subsequence, which I personally, I don't know, I like doing that. But most of you have been doing .split and then give it a second argument. I think the TAs have been showing that in recitation as well, that we're pretty upfront with, you can do that. But .split and then comma, usually 1, split on the first occurrence of this and give me 2 things. Much does most of what you want, to be honest. So it seems a little scary at first. We have to do byte parsing instead of string parsing, but Python makes this kind of a non-issue. But we do have to be careful of this. So we have to make sure that we're in the world of bytes, not the world of strings, when we're handling these binary file uploads. So to do that, 1, we already received the request as bytes. Also, the request constructor takes bytes, not a string. That was also very intentional for this reason. Takes bytes, not a string. You already read it from the TCP socket as bytes. So you're already in the world of bytes. You had to do extra work to get into the world of strings before. You had to do .decode to get that into strings. We're going to leave this as bytes and only convert it to string in pieces as we guarantee that those pieces don't have any binary data, non-text binary data. And then whatever we're looking for, we're going to create subarrays for that. So the first thing we need to find is /r/n/r/n. And in your code right now, you probably are, which I would expect most of you to be working in the world of strings at this point. Most of you will probably be decoding it to a string, the whole request, and then looking for this string that I have highlighted in your request. Look for the first occurrence of this. Importantly, don't split on these without adding that second argument, because notice for these requests, we by design have the sequence right here, and right here. We have it appearing 3 times, and the bytes of our file might also contain that sequence, which it will in my testing. So we don't want to split on this, but we can split on the first occurrence of this. In the world of bytes, what we're going to do instead is leave the request in bytes. Don't decode it to a string. Instead, we're going to encode this string. So you can still type this string and then encode it, or just slap a B at the beginning of the string. That'll do the same thing. And look for this subsequence of bytes, not this substring. So look for this sequence of bytes in the request, which again, Python just has a .split that works with byte arrays, so not that big of a deal. But just make sure you're working in the world of bytes for this. So encode this into bytes and then look for it in the request. Everything before the first occurrence of this sequence is going to be the headers. That's HTTP guarantees that. The browser is going to enforce that. So everything before that's headers. And what do we know about headers? ASCII only, baby. Once you get everything before this first /r/n/r/n, it's all headers. It's all not even UTF-8. It's all ASCII. So you can now convert that to a string and throw the headers in whatever code you already have that's going to parse your headers. Even if it works with strings, that's fine. Headers are always going to be strings, so you can still reuse that function that parses your headers and spits out a dictionary of all the name to value, all those key value pairs. Parse all the headers that way. You have all the headers, including the boundary, so you can get this boundary as a string, and then encode the boundary into bytes and look for any occurrences of this boundary, keeping in mind all your extra /r/n's, all your dashes, based on everything we talked about before. But we're going to encode this in bytes, so extract it, .encode, that gets it into bytes, and look for that sequence in bytes. The one thing I forgot to mention, it was one of the bullet points, but I forgot to mention it when we were on that slide. This boundary, the one requirement for this boundary that every browser has to enforce, or else they're not enforcing the protocol, is that this boundary cannot appear in any of the content that the user submitted. Any of the headers, anything. It can't appear anywhere in here because that's going to break all our parsing code. And that's why the boundary is such a long, scrambled mess of stuff. It's because this can't appear anywhere as a subsequence in any of the content, including the bytes of the file. This might be a gigabyte file. Anywhere in those bytes, it can't have this sequence of bytes. The browser will enforce this, and that's why the boundary is going to be different on every single request, and you have to read it from the headers. It's because that boundary can't show up in the content itself. So when we look for this boundary, it's not the same issue that we have with the blank line, where the blank line, those 4 bytes can appear in the file. It's just 4 bytes that in text has a special meaning, /r/n/r/n. But those same exact bytes might appear in a MP4 encoded video. That's perfectly allowed. That's something that it can do. So we have to be careful there. The boundary, we don't have the same issue. We can look for this boundary. Any occurrence of it will actually be a separation of the parts. All right, so we encode this in bytes and look for this sequence with all our extra dashes and new lines and all that stuff, and use that boundary to extract each part. Again, in bytes, we have to be very careful with this information because it contains some non-text bytes. And now we extracted a part. Once we get to the boundary stuff, we have this as bytes, and we're going to do the same thing we did on step 1. We're going to look for the blank line as bytes. Once we find the blank line as bytes, everything before its headers, we can decode that to a string safely. We can throw that in our function that takes any number of headers and spits out a dictionary to parse all this. And what we have at that point is the bytes of the file finally isolated. We handled everything after it. That was part of our boundary parsing stuff. Everything before it was when we're parsing this part and parsing the headers, looking for this blank line. Everything in between is going to be the bytes of our file. So now we have exactly the bytes of our file, and we can save these bytes to disk and do our file processing stuff. I'll leave it at that for now. We have a few slides of talking about what to do with this file. But we have the bytes of the file isolated without ever converting it to a string because we parsed in the world of bytes. And that's the end of our parsing multi-part conversation. So any questions on this? Because this is the bulk of it. Learning objective 1 on homework 3 is going through all of this, parsing any arbitrary multi-part requests. And then you'll use that code. The reason it's an LO1, and for the reasons I said before, is you'll use that code on all 4 of the other objectives. All 4 of the other objectives are going to get multi-part requests, and you'll call your... did I make it a function? I think I made it a function. You'll call the function that you wrote for LO1. It's already been tested by Autolab through my test. You know it works, so you'll have exactly the bytes of the file at that point. So it's very important that we can parse this format exactly, very precisely. So any questions on that before we move on to other things, other related things, but I'm not going to talk about multi-part parsing anymore. It does come with a little warning. I gave this warning in the other lecture, so I better, for completeness sake here. Multi-part parsing is one of them things where looking at this request, I don't think it's too hard to follow the lecture. I don't know. Maybe y'all disagree. I don't have a good feel for it. But following the lecture, I don't think it's too bad. When you go to code it, though, when all those little details mean you have to write a few extra lines of code, that's where it gets trickier. It's one of those things where I feel like you've probably already gone through at least 10 of these things in other courses where lecture is, oh yeah, I get that. That's super simple. And then you go to code and it's like, how the hell do I ever even start doing this? I think this is one of those things, so I would love to get some questions and clear up anything preemptively if I can. And I don't want to scare you. I don't think this is too hard to code either, in my opinion. It does trip students up. I know that. It's not easy, but it's not ridiculous. It is just parsing. You've been parsing stuff since 115. definitely different. I don't mean that this is a 115 level thing, but it's you've been developing these skills for years, is what I'm saying. You're ready for this level of parsing? There are no questions, so it must be easy. Moving on. All right, so we can now support file uploads. And what do? We have the bytes of this file, and in files, I feel like I've already said this semester, and you probably heard this in other courses, and you might just know this from just using computers. But files are just a sequence of bytes. Like, that's it. And then we add some kind of meta information, the file name and the file. Nope, that's not true. The file name we add to it to kind of say that, okay, these bytes are this file name and this directory and everything. But really what a file is just a bunch of bytes. We see this when we are sending our HTTP responses. When we have to read a file, we read index.html from disk, get the bytes of the file, the actual contents of that file, and slap it at the end of our HTTP response and send it over the internet. It's just a bunch of bytes. What the end user receives in that response is just the bytes. There's no sense of it being a file because it's not stored on disk at that point. It's bytes flying over the network, but it's the same exact bytes that were on disk, minus any HTML templating that you did to change the bytes a little bit in that example. Same thing with images, and being on the other side, we're receiving files. We extract the bytes from the request, and those bytes we save to disk. We're going to do our with open file name, comma W to make sure we open the file in write mode, as whatever dot write, and then the bytes of the file, and save those bytes to disk. So that's what we want to do with those bytes, is save them to disk. And a few notes on this: it's bad practice to store your files in a database. Databases are not optimized to work with big chunks, big blobs. They actually call them blobs, big blobs of binary data. That's not how databases are optimized. It's just bad practice to store your large binary files in a database. So what we'll do instead is create some naming convention first. I like image 1, image 2, image 3. You don't have to get fancy with this at all. Some of you like to use the GUIDs, the globally unique IDs for them. I don't care what you name your files, but have some naming convention that's not using the file name that the user supplied. You don't want to use their file name for the reasons we talked about earlier. You're going to get file name collisions, and you have another attack vector for injecting stuff into your server. If you're using their file names, they get to choose that file name. It's going to try to inject HTML. It's going to try to do SQL injection attacks. They're going to try to do everything they can with that vector. So just don't give them that option. So for a few reasons to have your own naming convention. And then in your database, you're going to store only the file name of that file. And there are, I'll say, better ways to do this, but the recommended way I'm saying in the homework, to get you through the homework, because I think this is what a lot of y'all will end up doing anyway, so I might as well just encourage it, is for homework 3, you're going to have your chat box, which you already have, and then you're going to create another form for file uploads. And when somebody uploads a file, that file will appear in chat. That image, we're going to support image uploads. That image will appear in chat just as another chat message. So we'll save that file to disk, and then as their chat message, what we can do is take the file name, or rather the path for that file, and add that as the source of an image tag and store that HTML as their chat message. So that's going to be my encouraged, recommended way to do this. So you'll have some chat messages that are actual HTML, not escaped, that's rendered as HTML on the front end. So when the chat messages path is hit, it's going to grab that, and it's going to be actual HTML and then rendered as HTML. But that HTML is completely controlled by your server, so it can be trusted in this case. Your server's serving up all kinds of HTML already. As long as you fully control it, which we're not even taking the user's file name, the only thing the user controls is the content of the file. So in the real world, we'd have to be cognizant of that, trying to think of what kind of attack they can launch by controlling the content. But for, actually, no, they can't. I take that back. For our purposes, we're fine with that. The content's just going to be the file name, and the file name's chosen by us. That's the other thing I was going to say. The file name's chosen by us. All of that HTML is completely controlled and generated by us. so we can safely just use it as HTML and render it as HTML. And then the source is going to be the path for that file, and you're going to host that file at some path, probably /public/image/ whatever naming convention you're using. And then the user is going to get that chat message, render the HTML, the browser is going to look at the source of that image, and then make a request for that image, and you'll host the image at a separate path. So you're not worrying about how to actually get the images sent when somebody requests all the history for chat. You're going to serve up the HTML, and the HTML is going to tell the browser to send another request for each image that's been uploaded to chat. So a little logistics there of how to handle that. Got ahead of my slides. Now we support file sharing. So users can, at this point, we effectively have like a 4chan clone. I need a better example of referencing. But we have an image bulletin board. Users can post chat messages and post images to that chat to share, whatever images they want to share. So we now support that, which is pretty cool. When you get to this point, like that's a lot to build. It's really cool to get that functionality from just a TCP socket. It's a pretty big accomplishment once you get to this point. Oh, doing auth too. Hell, just doing homework 1, I think is pretty cool. It's a pretty big accomplishment. And we won't be able to finish this conversation, but I'll start it. This is about where we got in the other lecture too. Oh, Reddit. Yeah, I should just say Reddit for that example. Well, we don't really have separate posts. That's the problem. Or commenting on posts. It is a better thing to reference though than 4chan. All right, so with hosting files, you'll build some URL scheme. If you're using the one that we've already been using, /public/image/ whatever your naming convention is, you can host them here. You can use something like query strings. You can use a different path. You can use like just /image. I don't care. The homework assignment doesn't specify what your pathing needs to be, but you're going to have some path that looks like this. And at this point, we can't use any hard-coded paths at all. We need something fancier. I'm recommending the router to handle this situation, but we need something where we can match paths that start with a certain string, which the router by default is going to do with the regular expressions. It has to start with that, even if you don't use any regular expression syntax. And then you can use the /dot like I showed last time. That's